Look up at the night sky. Within the vast darkness of the Aquarius constellation, there is a faint, almost invisible red glow. To the naked eye, it is nothing, just another speck of dust in the infinite void. But for those who know where to look, it is the most significant coordinate in our search for cosmic companionship. 40 light years away from where you sit right now, a tiny, ultra-cool red dwarf star is slowly burning through its fuel. We call it Trappist-1. It is not the star itself that captured the world's imagination in February of 2017. It is what dances around it. Orbiting this dim, crimson ember is not one, not two, but 7 Earth-sized planets. It is a crowded solar system, packed tighter than the moons of Jupiter, a place where if you stood on the surface of one world, the others would loom large in your sky, twice the size of our full moon, revealing their continents and clouds to your naked eye. For decades, we asked the question, are we alone? Trappist-1 gave us a tantalizing answer. Here, in this compact system, lie 3 planets squarely within the habitable zone, the Goldilocks zone, not too hot, not too cold. Just right for liquid water to exist on the surface, just right for life. But before we pack our bags for a 40 light-year journey, we must understand the reality of this alien neighborhood. It is unlike anything in our own solar system. The star Trappist-1 is barely larger than the planet Jupiter. It emits a fraction of the light our Sunday does. Standing on one of these planets would feel like standing in a permanent twilight, a world of eternal sunset. The proximity of these planets to their star comes with a cost, a heavy gravitational price that might turn these potential paradises into biological prisons. Distance changes everything. In our solar system, Mercury takes 88 days to orbit the Sunday. In the Trappist-1 system, the entire year of the innermost planet lasts only 1.5 Earth days. Everything here happens in fast forward. But this speed comes with a strange stillness. Because these planets are huddled so close to their star, astronomers believe they are tidally locked. This means the same side of the planet always faces the star, just as the same side of the moon always faces the Earth. Imagine the implications. On one half of the planet, the sun never sets. It is a scorching, endless day where the red star hangs motionless in the sky, forever burning. On the other half, the sun never rises. It is a frozen, dark wasteland, locked in an eternal night. If life exists here, it may not be on the burning day side or the freezing night side. Instead, it would cling to the edge. The Terminator line, a thin ribbon of perpetual twilight, separating the light from the dark. Here, the temperatures might be mild enough for rivers to flow. Imagine a civilization living in this ring of twilight, fearing the burning sun on one side and the frozen darkness on the other. The view from this twilight zone would be unlike anything humans have ever witnessed. Because the orbits are so tight, the other planets in the system would appear massive in the sky. If you stood on the surface of the 4th planet, Trappist-1e, you would see the neighboring planets pass overhead with terrifying speed and size. You would see their clouds, their ice caps, perhaps even their oceans, hanging above you like heavy celestial ornaments. It is a cosmic dance, choreographed with perfect mathematical precision. These planets are in orbital resonance. For every 8 times the inner planet orbits, the next one orbits 5 times, and the next one 3. It is a gravitational harmony that has kept this system stable for billions of years. But stability does not mean safety. The star that gives them warmth is also their greatest threat. But let us look deeper. Let us strip away the romanticism of finding a new Earth and confront the violence of the cosmos. Trappist-1 is a red dwarf, and red dwarfs are temperamental parents. In their youth, they are prone to violent tantrums. Massive solar flares, bursts of X-rays, and ultraviolet radiation lash out into the void. Because the planets are so close, 20 times closer than Earth is to the Sunday. These flares do not just wash over them, they assault them. For billions of years, the solar wind has been stripping away the atmospheres of these worlds. It is possible that the inner planets, Trappist-1b and C, are not lush worlds at all, but barren rocks, scorched cores where any drop of water boiled away eons ago. They may be dead worlds, victims of their star's proximity. However, hope resides further out. We turn our gaze to the jewels of the system, Trappist-1, D, E, and F. Let us descend onto Trappist-1e. This is the planet that keeps astronomers awake at night. It receives about the same amount of light as Earth. It is very likely a rocky world with a significant iron core. But because of the tidal locking, the climate here would be a chaotic masterpiece of physics. Computer models suggest something extraordinary, the eyeball Earth scenario. Picture a world where the day side is a permanent, boiling ocean, covered in a thick layer of reflective clouds that shield the planet from overheating. The night side is a continent of ice, a global glacier kilometers thick. But in between, along the Terminator line, lies a ring of habitable open water, a circular ocean that flows forever around the planet. If you stood on the shore of this twilight ocean, the wind would always blow from the dark side to the light side, a constant, howling gale driving the weather systems. The sky would be a deep, bruised purple. The plants, if they exist, would not be green. To absorb the weak infrared light of the red star, vegetation here would likely be black, or perhaps a deep, dark red, a crimson forest growing under a crimson sun. Then there is Trappist-1f, slightly further out, slightly colder. If Trappist-1e is our alternative Earth, then Planet F is our alternative Mars. But a Mars with a twist. It might be covered in a frozen shell, an ice ball. Yet, beneath that ice, heated by the tidal forces of the other planets tugging on it, there could be a subsurface ocean, just like Europa or Enceladus in our own system. But on a planetary scale, a dark, warm abyss where life could swim, protected from the deadly radiation of the star by miles of ice. The most fascinating possibility, however, is not just life on one planet, but life on all of them. This system is a perfect candidate for panspermia. Because the planets are so tightly packed, an asteroid impact on one could eject debris into space that is easily captured by the gravity of a neighbor. If life began on Trappist-1e, rocks carrying microbes could have traveled to Planet F or Planet D in a matter of years, not millennia. It is possible that this is not just a solar system, but an ecosystem. A family of living worlds sharing the same biological heritage. But how do we know? We are not guessing anymore. We have entered the era of the James Webb Space Telescope. Right now, as you watch this, the golden mirrors of the James Webb Telescope are peering into the atmospheres of these distant worlds. It is using a technique called transmission spectroscopy. When the planet passes in front of the starlight filters through the planet's atmosphere. The gases in that air absorb specific colors of light. By analyzing the missing colors, we can read the chemical fingerprint of the atmosphere. We are hunting for biosignatures. We are looking for the holy trinity of gases: oxygen, methane, and carbon dioxide. Separately, they mean little. Oxygen can be produced by rocks. Methane can come from volcanoes. But together they imply biological activity. They imply breathing. If we find these gases in the atmosphere of Trappist-1e, it would be the greatest discovery in the history of our species. It would mean the universe is teeming with life. But there is a final haunting thought that makes Trappist-1 even more important than our own solar system. It is about time. It is about the end of things. Our Sunday is a yellow dwarf. It is bright, it is warm, but it burns its fuel quickly. In 5 billion years, our Sunday will swell into a red giant, consuming the Earth before collapsing into a white dwarf and fading away. Our time in the sun is limited. Trappist-1 is different. It sips its fuel. It burns so slowly and so efficiently that it will live for trillions of years. When our Sunday is dead, Trappist-1 will still be in its infancy. When the Milky Way collides with Andromeda, Trappist-1 will barely have aged. Long after the last yellow star in the universe has burned out, long after the universe has grown cold and dark, the red dwarfs will be the last campfires remaining in the void. These planets, these dim, red-lit worlds, are not just a curiosity. They are the future real estate of the cosmos. If humanity, or any civilization, is to survive the death of the stars, we will inevitably have to huddle around tiny red embers like Trappist-1. Perhaps 40 light years away, someone is already there. Perhaps they are looking back at our bright yellow star, wondering if life could possibly exist in such a violent, short-lived blaze of light. They might pity us for our brevity, while we pity them for their darkness. Ultimately, the Trappist-1 system is a mirror. It reflects our desperate desire to find a connection in the dark. It challenges our definition of a habitable world. It reminds us that nature is far more creative than we are. Whether these 7 worlds are barren rocks or thriving ecosystems, they prove one undeniable fact. The universe is crowded with potential, and the search has only just begun. As we stare into the Aquarius constellation, we are no longer just looking at stars. We are looking at destinations.